let's take a deep dive into how this mug works. The heart of the mug is the ADXL335 Accelerometer. I'm using an Arduino purpose-built board, much like this one. What's nice is this chip outputs directly to analog. This board in particular has a 3.3 volt regulator built right onto it, so it can be hooked up directly to 5 volts. It is important though to remember that this chip does run on 3.3 volts, as the output is going to be based on that. The Arduino, on the other hand, runs on 5 volt logic, so you don't get the full range, but you still get enough to work with. And with more circuitry, we could get this a little better, but we're going to roll with this today. Here's some simple code to read the analog signals off the chip. All we're doing is using the analog read function built into the Arduino software. As you can see when I move it, the value that is displaying on the screen does change. The only downside is when you hook up the chip directly to the Arduino, you only get about 270 to 410 units of range. So with some extra code, you can make this a little bit more convenient for projects. This code in particular grabs a 0 at the beginning of startup and then uses that to determine if the accelerometer has moved at all. So as you see down here in the serial monitor, it's reading mostly 0, 1, but if I tilt it on a specific axis, it'll tell me immediately that it's been tilted. We add a little bit more code and we get this. So I'm using the map function to take the measurements coming off the chip and turn it into degrees, so it's a little bit more convenient for our brains to work with. And so as you can see, if I rotate it to about a 40 or to a 90 degree angle, it gets roughly 90. It's a little hard to hold it at 90 exactly, but how does this pertain to the mug? So all the mug really looks for is whether it's been tilted past a certain degree marker. In this case, it's 30 degrees, just because it was a convenient number and it was very reliable and read. I did run into one issue while working on this project, and that was when anytime the servo was moving, the accelerometer measurement would go all out of whack. This was because the servo was pulling enough current that it would affect the analog signaling between the Arduino and the accelerometer. A couple ways you could fix this. One way is to isolate their power circuitry. You can do that in a few different ways, or the easier way is to just put a delay in, which is what I did because, again, the easier way. And all that does is keep the accelerometer from being read whenever the servo is moving. And that's basically it. The ADXL335 is an excellent accelerometer, especially since it uses analog output. It leaves all your digital pins free for you to use for whatever you need in your project. I hope this helped you out. If it did, please like, subscribe, that helps me out. If you'd like to see the video about this mug, it's going to be linked right over here. And I will see you guys in the next video. Have a good day.